Hi. My name is Michael and I invite you to watch a tutorial in which we will discuss pagination in Django. Or more precisely, in the Django Rest Framework. The tutorial is divided into 5 parts. In the first one, we will prepare a base Django application to work on. In the next part, I will show you how to implement the base pagination in Django Rest Framework. In part 3, we'll create our own pagination class to use. In part 4, we'll add extra functionality, extending the functionality of the pagination class. Code cleanup and a brief summary is the 5th part. The application is available in the GitHub repository, which you can download to analyze the code in more detail. You can also program along with me, which I encourage you to do, because as we know, there is no better way to learn than practice. If you find useful information here and the way of sharing knowledge interests you, I encourage you to subscribe to the channel. Here I will be presenting tutorials on programming in Python, Django and Vue.js. If you would like to contact me, I invite you to visit my website, where you can find links to my social profiles, or send an email to the address provided. You'll find links to the sites and repository in the comments. Enjoy watching the tutorial. Okay, let's start by checking out what Django Rest Framework, DRF, offers in terms of pagination. As we can see on the DRF documentation page, adding pagination is child's play. If we want to add pagination to all list views we have in the application, it's enough to define the settings in the settings. DRF offers us 3 basic pagination classes. The first one is page number pagination, in which we specify the page number in the query parameters, and in response, we receive the number of records, addresses for the next and previous page, and the found results. Another pagination class is limit offset pagination, which responds in a similar manner but differs in query parameters. Here, we specify the first record from which we want the data and an offset defining the number of records we request. There is also the cursor pagination class, but I honestly never used it due to the limitations you can read about in the documentation. In this tutorial, we'll use page number pagination. Let's first take a look at the attributes and methods this class has. As you can see, there are a few interesting attributes. We'll be using them shortly, but what I'd like to draw your attention to now is the method getHTMLContext, which, as you see, returns not only the addresses to the next and previous page but also the page links object. The page links object is an array with links to paginated pages, thanks to which we will be able to easily open pagination links, similarly to traditional pages in the Django framework, with correct page numbers as we see here. This is, of course, an example of HTML code as it offers us traditional views and templates in Django. The final effect that we want to achieve can be checked in the paginator class used by Django views. What we want to achieve is a pagination class that will return us a list of URLs based on which we will create pagination buttons as we see here in this example. Okay, now that we know what we want to do, it's time to get to work. Let's start by preparing our Django application. To create a Django application quickly and well, we will use Django Cookie Cutter. For what Cookie Cutter is a very convenient and fast solution, you can use it working in virtual environments, virtualenv, or if you prefer Docker, you can use Cookie Cutter to generate an application working in a Docker container environment. I personally prefer Docker, and this is what we will do: install the Django application with Docker. Let's copy the command and fire it up on the SSH command line. Now we have to answer a few questions: give the project name, author, select license, select user, etc. At the Docker question we of course select yes, although this of course depends on your preferences, you don't have to stick strictly to what you see here. Next we select cloud provider mail server. When asked about DRF we select yes, which will immediately install the Django Rest Framework. For static files, select white noise support. Once installed, fire up your favorite code editor. I use Visual Studio Code. One of the first things I do in every project is to create a makefile, where I place the basic commands that I will later use when working with the project. For now, literally a few commands like docker's run, build, and of course migrations and migrate will suffice. Locally, I work using Docker Compose. Cookie Cutter automatically prepares a Docker configuration file. For the local environment, this is the local.yml file. With such a prepared environment, we can get to work. An important command that we will certainly still use and that I didn't mention earlier is, of course, the python manage.py shell command, which will allow us to use the Django application shell. Let's also add it to the makefile. Running an application in a Docker environment is very simple. Thanks to the previously prepared makefile, all you need to do is run the commands make build and make run in the SSH console. Of course, the make build commands are executed only once before the first launch of the environment. Okay, after a short while, we have a working local environment that we can continue to work with. As you can see, the application is in Polish, which is a result of the web browser settings. For readability, I will change the settings to English. As I mentioned, the application is ready to work with basic models, forms, and useful development tools. First, let's add a superuser. Unlike the command python manage.py shell, which I added to the makefile in the meantime, create superuser is not something we do often, so let's just add it once, without adding a separate command to the makefile. Docker allows us to execute a shell command in a specified container, and this is exactly what we do. If you are working in a virtual environment, just do the same from the SSH console in the project directory by entering python manage.py create superuser. Okay, I see we have an error. No such service, Python. Of course, if we look at our Docker configuration file, which I've already mentioned, local.yml, we see that our application uses a service named Django, and this is the name we need to provide in the command so that Docker Compose knows where to execute it. Now everything works correctly, superuser created. Please also quickly correct our makefile so that the other commands work correctly. As I mentioned, the application is ready to use. We have user models and basic views that we can utilize. The user serializer returns basic information about the logged-in user, and for now, we won't be changing this. This view and serializer are entirely sufficient for us to discuss pagination, which is what we're focusing on in this tutorial. For playing with our API that returns a list of users, we will use a tool named Postman. If you're following along with me, you can, of course, use another tool that you know and like. I've gotten used to Postman, which is convenient and offers a range of possibilities, even in its free version. To keep things organized, we will save our requests, or rather one request, retrieving the list of users stored in the database, in a folder named Pagination. Upon entering the address to fetch the list of users and sending the request, as expected, we receive a user authentication error message, authentication credentials were not provided. Let's quickly look at how the base cookie cutter application we installed handles user authentication. As you can see, we have user authentication support based on session or token. Therefore, it's straightforward to generate a token for the user and add it to the request headers. Let's do that now. In the administrative panel, go to the token model, and select New, choose a user, we have one for now, and click Save, which will create a token for this user. We can now copy it and use it to authenticate requests sent from Postman. In Postman, in the Authorization tab, we select the option API Key and insert our newly generated token for the user Statura. Now when we make the request we get the correct answer. Testing pagination with only one record in the database is pointless. Therefore, we will now quickly add users so we can test our changes on them. For this purpose, from within the Django shell, we will write a very simple script that will add 10,000 users. To generate unique values in the username field, we will use the UUID library. Of course, let's not forget to use bulk create, unless we want to make a coffee while the application is creating users for us, then we can write a script using a simple create. Let's also check if it correctly added 10,000 users, and as we can see, everything is as we planned. We have 10,000 random users in the database and we can list them using pagination. As we can see, we still get only one user returned. Let's see why this is happening. Okay, as you can see in the getQuerySet method of our view, which returns us the list of users, we have created filtering that protects the application from listing all users. When retrieving data about users using this view, we can in fact only retrieve information about ourselves. This is sensible and secure, however, in our case, it's cumbersome, so for the purposes of this tutorial, we will comment out this part of the code so that the endpoint with the list of users returns data on all users. After saving the changes and sending the request again, as you can see, after some time, the API returns a list of all 10,000 users saved in the database. So we have a ready-made development environment. Let's move on to pagination. Alright, let's add pagination to our project. Let's revisit the Django Rest Framework documentation for a moment. There, in the description of pagination, under page number pagination, we'll find a ready recipe for adding pagination to the views of our API. Let's copy these settings and add them to the settings file, to the REST framework key. Let's also replace the apostrophes with proper quotation marks and see how it works. The page size is set to 100 results, and that's exactly how many we expect to receive in response at the endpoint returning the list of users. Now, as you can see, after making a request, we get a somewhat different response. Most importantly, we get a count key containing the total number of records. We also have next and previous, with URLs to the next and previous pages. Since this is page number 1, previous has a value of null. In results, we have the first 100 records from the database. We can easily change the number of records returned in the settings by specifying the desired page size parameter. To change the page, we provide the page parameter with the appropriate number, and in response, we get the respective values in next and previous. Of course, the results in results are also correct and reflect the next 100 records for page number 2. For now, as you see, nothing new, but I wanted to show the operation of pagination from the very beginning, so it's easier to understand the changes that we will be implementing shortly. As you remember, our goal is to obtain links not only to the next and previous pages but also to the other pages that will be presented similarly to traditional Django templates. We want the response to include what the paginator class returns in the getAlightedPageRange method. To detail, our goal is to receive a response with two main keys, results and pagination. We'll leave results unchanged, but for pagination, we want it to return the following keys. Links, containing a list of links to the pages that will display in our component. Current page, containing the number of the current page. Page size, returning the number of records. All pages, with the number of all available pagination pages. Total records, containing the number of all records available in the database. Alright, since we've established our goals, it's time to get our hands dirty. In the main directory of our application, let's create a subdirectory called utils and within it, a file named pagination.py. In this file, we'll write our own pagination class for the application to use. Let's name the class Custom Pagination. As you can see, this class inherits from page number pagination, which will allow us to use its methods and attributes. Of course, let's add the necessary imports to the file. First off, let's add the ability to define the page size and the number of records returned via a parameter. To do this, let's define page size query param and give it the name page size. This will easily allow us from the front-end application to define how many records we want to receive in the response. Generally, the response object is returned by the getPaginated_response method. Wanting to introduce changes, we will override this method in our class, adding additional elements. Our response, as you remember, will contain two main keys. Results, with the data, in our case, it will simply be data, and pagination, with the pagination object. We'll see if it works as we want for now. In the settings, let's point to our custom pagination class that we're working on and see what the sent request looks like, or rather what the received response looks like. It seems that everything is working well. Our application is now using the custom pagination class we are continuing to work on. In the pagination key, let's first add page size, which is returned in the page number pagination class in the getPageSize method. The method takes request as a parameter and returns to us the default page size, or the one defined in the request parameters. Let's also add all pages, which we will get from the number pages attribute of the paginator class. And total records, which is returned to us by the count attribute, also from the paginator class. After saving the changes, we'll see if everything works as we expected. As it appears, everything is functioning correctly. We'll also see if changing the page size parameter affects the response. As you can see, it works. We can now flexibly manage the size of the response using this parameter. Okay, let's add current page, which will be returned to us by the getPageNumber method, to which we must pass the request and the paginator class. Let's convert the value to a number using Python's int to ensure that a numerical value is always returned in this key. As you can see, it works correctly. Current page returns the current page we are on. This information will be useful for marking the current page. Finally, let's add links to the individual pages. As you remember, in the PageNumber pagination class, we have the getHTMLContext method, which according to the documentation, will return what we need. Let's see if that's the case. In our class, let's add in the response a links key returning the getHTMLContext method. And voila! After saving the changes in the API response, we receive links to the individual pagination pages as we wanted. So, we have a link to the previous page in the previous URL key, a link to the next page in the next URL key, and page links containing a list of the individual pagination pages, which we will be using in our front-end application. Page links is a list of objects, each of which represents a link to a different page. Each of these objects is a list that contains 4 elements. In the first place we have the URL to a specific page, then the number of the page the link leads to. The next value specifies that the link leads to the current page. A value of true indicates that it does. The last value indicates whether the element is a break. Break, in other words, if we have the value true, here the front-end application will display 3 dots. As you can see when we change the page to a little further away, say to page 10, page links shows us these breaks in 2 places at the beginning and end of the object. To summarize, the getContextHTML method allows us to easily build a user interface for navigating through the pages, providing the information necessary to display links to individual pages, as well as links to the next and previous page. This will enable us to create more interactive and accessible web applications that use pagination of data. Okay, let's now move on to the last thing I wanted to show you in this tutorial. With the various projects I've done, I've often found myself in a situation where I needed results without pagination for a particular view. For example, the list of users we retrieve from our endpoint is paginated, but let's imagine a situation where we implement a user search engine or any filtering in our application. In this case, we would like the application to receive the data without pagination, simply all the records found. Let's see how this works for searching for users by their username from the username field. For this, let's still first check if our application, in general, supports filtering and searching in views. Okay, as you can see we have an app called DRF Spectacular, which has support for Django filter. Great. We're good to go. In our user view we add a filter import. We indicate filter set class as search filter. In the attribute search fields, let's specify the fields of the model user by which we want to search. In our case it is username. I save the search fields as a tuple. We can, of course, define it as a simple list, but here I would like to explicitly point out that it is a non-mutable value, and let us not forget that this will save a few bytes of server memory. A small side note here. If you are at a stage in your programming life where you do not yet feel the difference between a list, a tuple, or an object, it is worth taking a break and reading about the possibilities and limitations we have when using each of them. Okay, let's meanwhile get back to our project, see if the search engine works. As you can see, it doesn't. We also don't have any errors returned to help us understand the problem, so I'm assuming we have either a typo or an incorrect implementation in the search. Let's go back to the documentation. We have a link here that should help us. Let's see what they wrote there. Okay, as you can see we actually have an error. The attribute that specifies the filter we are using for the search is called filterSetBackend, not filterSetClass. Let's correct that, save the changes and see if it works. As you can see, it works now. Given the search parameter, we indicate the phrase that Django Rest Framework is looking for in the username field. It found us one user, and we can already see that the pagination information is completely unnecessary here. Maybe let's search for a bit more users. Let's check how many 007 agents we have in the user base. Okay, as you can see it has found us 35 users who have the phrase 007 in their name. However, here too the whole pagination object seems redundant. The question is how we can remove it, and whether it will be returned controllable from the front-end application. Okay. In our class that we use for custom pagination, let's use the PaginateQuerySet method. This method is part of the PageNumberPagination class that we inherit from. We can override it in our class by adding new features to it. The parameters of this method are, in order, the query set containing the elements to be paginated. This is a list or dataset from which you want to return only a specific part. A request object that contains information about the current HTTP request. DRF uses this object to determine which page to return, based on the request parameters. View. An optional parameter that represents the view from which the PaginateQuerySet method was called. This parameter can be used to access additional information about the view or to modify data based on the view logic. Although we will not use it in our example, I describe it so that you have a complete set of information. Perhaps in your projects this information will be useful. The PaginateQuerySet method deals with splitting the entire data set, query set, into smaller chunks, pages, based on the parameters passed in. Here are the main tasks it performs. Determines the page size, number of elements per page, based on the pagination settings or a default value. determines the current page number based on the parameters passed in the HTTP request, cuts the appropriate section of the query set, corresponding to the elements belonging to the requested page, prepares information necessary for page navigation, such as links to the previous and next page. Knowing already how this method works, we will use it for our purposes. We will use the predefined page size query param for this, checking if it takes the value all. If it does, then the method returns all results without pagination. If, on the other hand, it is a different value or no value at all, we let the method run unchanged by calling super. It is worth mentioning here that the paginate query set method of the page number pagination class does not support the page size parameter as a string value. Only by overriding this method we can extend its functionality and add support for page size equal to all. Let's now check that our changes are working as we wanted them to. To start with, let's call the user list without any changes. As you can see, we have correctly returned the results along with the pagination object. We can say that we have already had half of a success. Now let's do the same query but specify the page size parameter with the value all. Passing this parameter with this value should return us a list of found records but without pagination. And indeed it does. So, finally we have a very flexible pagination class that we can use in our front-end applications, which we will do in the second part of this tutorial. Finally, let's do one more thing that, in fact, we should always do before making a commit to our repository. Let's clean up our code a bit. Okay. We should still add tests, but this tutorial is not about testing the application. Here I wanted to show you how we can add our filtering backend to all the views at once. As you may have guessed, we need, according to the Django Rest Framework documentation, to add an entry to the settings defining the default filtering mechanism that will be applied to the views. So we add default filter backends key to the settings and, at the same time, from the view itself we can remove the definition of filter backends and remove unnecessary imports that become redundant. Let's save the changes and see if we haven't messed anything up. Oops. We did mess up, though. Unlike before, this time, we have an error message which should help us find the cause of the problem. The error message says, type error, type object is not iterable. Okay, this is probably one of the more common errors we can encounter. I'm betting we have a tuple without a comma at the end, and indeed we do. Let's add it and see if that solves our problem. It works. So we have filtering and searching added to all views, we no longer need to define them in each view separately. In this tutorial, we have completed the process of creating our own pagination class that can be used in applications developed with the Django Rest Framework. Our class is based on inheritance from DRF page number pagination class, which allows us to access all the attributes and methods of the base class. The key function of our class is to return an object that contains two main elements, pagination and results. This structure provides simplicity in the use of the received data, allowing us to easily pass the complete pagination object to the pagination component of the front-end application. In addition, in our class we implemented the option to specify the number of records returned in the results segment. This functionality, represented by the page size parameter, significantly increases the flexibility of the class, allowing you to adjust the amount of data to the needs of individual application components. Introducing the ability to set the value of page size to all further opens up the option to choose between pagination and receiving all records at once, which in my experience is a functionality that is highly desirable in many scenarios. I hope that this tutorial has been for you, a valuable and comprehensive resource for creating and applying your own pagination class in Django Rest Framework. I believe that the information presented here will be useful in your projects. In the next episode, we will turn our steps towards a front-end application using Vue.js. We will zoom in on the process of building an application that not only effectively displays a list of users with pagination, but also includes a search function, presenting the results without their pagination. I hope you'll join me in this part of our programming adventure as well.